How are you doing? Welcome to today's, this is another Saturday recording, but by the time you're watching this, if you are in the United States, happy Father's Day to all the dads out there. I hope you get a nice, relaxing day. This is my attempt to add a little bit more value to your Fusion 360 experience. Just sitting down here trying to get through some emails, and hopefully you can find value in some of them. I am not really sorting through them. I'm just kind of like grabbing about 15 of them and then just hammer through them down. So if you like this, thumbs up. If you don't, that's okay. Thumbs down. And as always, I love your comments. I really appreciate when you take the time to do that. So let's jump into the first question here. This is from Anthony. Hello, Lars. I have a part I'm trying to draw in Fusion so I can print it out. 3D printing. All right. The problem I have is I made a cylinder, which I use the sweep command, and both ends are at an angle, but I'm trying to kind of adjust that angle of that cylinder, get the right angle on those. Watch some of your videos. Trying to do the offset plane, using the plane. Okay, let's get into Fusion. So, Anthony, I read your email a couple of times. I'm not 100% sure I quite understand exactly what you're looking for, but you know what? I'm going to take a whack at it anyways. So, if we go in here and create some kind of a cylinder, Z for circle, and let's make this one 100. I'm going to do kind of like O for offset, so we kind of get a cylinder shape and not just a round, maybe -5. And you said you're using the sweep command, what means that you need 2 sketches. So we also need a path. The sweep command is sitting right down here. So let's go ahead and create a second sketch here. So now we're looking from the top down. We're going to hit alpha line, so the line tool. Draw up a line here. Let's let's go up to about here. And you see how, here's a trick that maybe somebody didn't know. You see here how the line tool is active. Did you know that if you are in the line tool and you move without clicking anything, just drag your mouse, if you move back to the original, the point where that line came from, and you hold down the left mouse button, then it becomes a tangent arc. Ha! Yeah, that was a new one. So let's throw out there and hit the, and let's just end it right there. That was a little trick there. Line tool can actually create tangent arcs. All right. Rewind back if you want to see that one again. So with this, let's go back up to solid. Let's go in and do a sweep. So we have 2 selections in the sweep command. One is a profile. Select that profile there, and the other one is the path. Click that, and we get kind of a cylinder here, looking like this. And if we click on the top view, we can kind of see there's a little bit of an angle kind of thing here. I actually, when I used to work at Ridlam, I had a project where this command, if I couldn't figure out how to do this for the sake of, but this is the tool to do that. All right. So reading your email, Anthony, looks like so let's try to cut this tube here in a specific angle that we want to do. And you had watched the live stream that I had done a while back on using these different constructions planes. And you referenced that there is a plane along a path. But there is. So you can click on plane along a path. You will see that it's looking for kind of a path. So if we go over to the sketches over here and we turn that path on we created, you will actually get a plane that will walk around that path. And wherever you let go, it will actually, you can also put in dimensions or distance, but you can bring it over here. So if we drag it all the way to there and then we let go, now we have a plane in that angle there. What is great now. But if you wanted to cut this pipe in a certain angle this way, you will see that when you go in to do if you're going to do a plane and an angle, it's actually looking for a line, and we don't have that line. So what you could do was you could create a sketch on this plane. Right now we're looking here. Hit alpha line, and you could draw a line vertical up here somewhere, right? And just place that line somewhere. This is kind of a construction line. And now, because we have this, you could go back out of this sketch and go back into the plane at an angle and select that line. And now we actually do get a plane that could go through there in some weird degree, whatever it is you want. Now, what is kind of neat about this is that if we then hit OK to this and we use the split body tool, like that, and say we want to split this body with this plane, hit OK, you will see that it's split it. Now, but it still has the piece here. So you could go over to the bodies folder. Now you will see that there's kind of two different bodies over here. And there is that little sliver we want to get rid of. Right click on that body and hit remove. Like that. And it will it'll remove that. Now what is kind of neat about this technique here is that if we ever go back into the original along the path, we go in and edit that, and we maybe drag that original plane all the way back to here. Now when we hit OK, everything else is kind of kicking in, and that cut will be right there. So this any dimension we put in here is actually parametric in the sense that wherever we're moving that, that is going in there. So I think that this was where you were kind of trying to get at, Anthony, as an end result. And of course, if I go in and I change that that degree I had in here on this plane, let's do it 130, that will reflect that too. But oh, now it's actually cutting through. See how that plane? See how we suddenly got a sliver down here? This is a good one. This is a typical example where you're modeling something up and you're like, why did I suddenly get this sliver down here? That's not fair. What happened was that when we go over here and we right click, edit feature, our split body is actually splitting in to that other one because it's using that plane and it's splitting that body with that plane going all the way through it. Now, if this was where we wanted to leave it, you could go in and use this combine tool over here, and you could join this body again with this body here, and then that would have been fixed up. Okay, that was maybe... You know what, Anthony? Let me show you another way before this video becomes, this section becomes too long. What I probably would have done was actually, if we go all the way back down to where we had this. So we had the two sketches and we had the extrusion. I have always kind of considered this, I don't want to say it's cheating because it's not. It's perfectly okay. But I always felt like that's got to be a different way. But this technique I'm going to show you now is probably actually the easiest and probably, you know, I think it is legit. What we could have done, if we forget about all the stuff that I showed you first, we could just have drawn a sketch on this top plane here, and then we could have sketched a line. This is probably what I would do. I would sketch a line outside our shape, make sure that one is vertical, come over whatever distance you want, go in an angle here, maybe up to here and there, and then you could do something like a D for dimension and make sure that this angle is whatever you want it to be. So let's make it 28. Now, if I was going to do this and this was something I was going to send to a customer, I would probably actually fully define everything. So I would go in here and make everything in here fully define and make it totally black, right? You know, most of you guys know what I mean when I say making things fully black. So I would go in here and dimension everything. But my point is that the angle dimension I just created is the one that is the most important one. See, now it's fully defined. This 28 degrees could be the one, and then you could do a Q, and then just do a symmetrical cut through here, and you will kind of end up with the same thing as before. Now it's just this sketch that is driving that angular cut. That is probably what I would actually end up doing. Again, I feel like as a CAD application engineer, this whole thing about sketching up might seem a little, but the other one does create a lot of work in that sense. Anthony, I hope this was somewhat useful. I hope I understood your I hope you understood your email. If this was useful for anybody's watching this, thumbs up. If you like it, thumbs down if you don't. It's okay. Love your comments. Love the perspective. All right, let's jump into another one here. The next one is from Eric. Hey Lars, thank you for all you do. Hey Eric, you're so very welcome. Learned a lot from your webcast. Absolutely awesome. And you know what? Here is a really good one. My question is to keep a hole centered between two lines. And if I redimension one rectangle, how do I keep the hole centered between the two? And he actually showed me a picture. So I will share that picture with you. So this is what Eric sent over. So we have kind of a couple of rectangles, and we have there's a small hole right here that he's trying to keep centered, I'm assuming, between these two rectangles. So let's open up a new document, and let's model up the two rectangles. And this was actually in English. So let's jump from metric over to inches. Hit OK. You can always set that as your default if you want to. And geez, I gotta call up Eric's dimensions again. So we have a 4x2 rectangle with a 375 with 175 in there. All right, let's see if we can do that. New sketch, and I'm just gonna sketch on the top face here. I'm gonna hit my S key. That gives me my center rectangle. And what was it? 2x4 inches was the first one. And right click out in space. And let's do a repeat center rectangle. And the next one was 1.75 by 3.75. There we go. Two rectangles. So that mimics what Eric's trying to do. Then we're inserting. Can't speak. I'm sorry, folks. Then we're going to insert some holes in between here, but we want them to stay in relationship with the hole and always be in center. So what we're going to do is we're going to hit C for circle, and I'm going to draw a circle in here. Now, I know that when I looked at the drawing from Eric, it was 0.0262.5 in there. So now we have that little hole. I'm just going to grab the dimension and move it out there a little bit. So what we are looking to do is we're actually looking to place some dimensions that center it up. And you could do this with some center lines and attach it to that. But I want to show it with dimensions. So what I'm going to do, because I can see that Eric had kind of already started to do that. So let's just go out and place two dimensions, one here and one from this edge to this edge right here. Now, right now, these two dimensions are referencing the outer edge. Now, I did something similar like this not long ago where I utilized parameters, but today let's not utilize parameters. Let's do it all in the dimension field. So what we can actually do is we can do math, Eric. So what we can do is we can double click on the first dimension. This is the horizontal dimension for this. Double click on that, and then we can start doing math. So what we need is we actually need the outside dimensions. So what I'm going to do is I'm going to do a bracket, and I'm going to go down. I'm going to find this 4 dimension. I'm going to click on this 4 dimension, and you will see that becomes D1. Okay. D1, because each dimension that you see in here actually gets a number to them. The reason I'm clicking on them is because I can't remember what was assigned to them. Minus, and then the other horizontal dimension was this one. Now you see that is a D3, and this is, it just gets assigned in the order you want. But if we close the bracket and we do it divided by, well, by 4, and hit enter, that will place, and you will see that we get a fx, that's a calculation, that will place that in between there. So now we can do the same thing in in the y direction. So we click on this dimension, double click on this dimension so that becomes active, do a bracket, and let's do this one, what is apparently is D2, minus this one, what is apparently is D4, and do the same thing divided by 4. Now, anytime we're changing these dimensions, that will reflect on these holes. Now, I'm assuming, Eric, that you actually maybe need 4 holes around here. Actually, so what I would do now is I would actually test it. That's actually probably the right thing to do. So if we go in here, we double click on 2, and we made that 4 also, you will see that this distance is capped between these two with that hole. But it's going to keep the x direction in there. Of course, if I change this to 1, then you will see that it's going to do that math. Okay? Now, I'm assuming, and this can be dangerous to assume things, but I'm assuming that you maybe want 4 of these holes. So you could go around and do it all. But what I would actually do is I would hit C for circle. I would place 4 circles about where they are going to be. So somewhere around there. Okay, that's about where I want the 4 circles. Then what you could do is you could go in and say, I'm going to use these relations for the rest. So I can say, I know that I want this hole to be horizontal to this hole. That's going to move that up in that direction right there. I actually also know that I want this hole to be vertical to this hole. And I know I want this hole to be horizontal to this hole. And I know I want this hole to be vertical to that hole. So you can use these constraints to kind of move everything into place. Now, I also know that I want them all to be the same size. So I can go up and do the equal. And I can say I want this hole to be equal to this hole. Oops. To this equal to this. So now this 63 here is driving all these holes. Right? So now I just have to change them one place, and they all are kind of moving along. Now, I also know that right now, this hole here can't move up and down, but it can move along there. So what I could do was I could say, you know what, I'm going to do a dimension from this edge to this one. But instead of adding in all that calculation, I can just actually go over and click on this dimension here, hit enter, and now that will be equal to what that dimension is. And I can actually do the same thing if we go down and look at these dimensions down here. You can see that they're kind of like following the same thing. So I can do D for here to where that goes. And instead of typing anything in, I'm going to click on the vertical one and hit OK. And now they are all fully defined, and all 4 holes will now follow. So if we're changing this to 125, all 4 holes will be 125. If we now deciding we're going to change this again to maybe 0.5, all the holes will follow that. Change this to 0.75, all the holes will follow that. That's a lot of stuff in there, especially if you're brand new. And again, there's different ways. There's many different ways you can do this, Eric. But I think that if you get And if this was going too fast, just go back and re-watch this section again a couple of times. Maybe get a cup of coffee or something. But if you're a new user out there, taking the time to learn these kind of things can be really, really helpful. I know it's a little frustrating in the beginning because you just want to get something up at the screen, whatever you're trying to do. But honestly, if you take the time, I think you will find this very valuable as you're going through. Thumbs up if you like it. Eric, thumbs down if you don't. Love your comments. If you haven't subscribed to the channel, that will mean the world to me if you do that. Thank you. Okay, let's move on here. So that was to design. Let's jump into a cam. That's got to be an equal trade. Some people don't like the cam portion. I'm sorry, but I'm just answering these questions in pretty much in the order I'm getting them in. I'm not filling things out. So if it's cam, it's cam. If it's 3D printing as later on, then it's going to be 3D printing. What can I tell you? All right, the next one is from Philip. Philip have sent a request in regards to, there's a picture going along with it. That was why I switched the screen over. Here is a picture of this. Hey Lars, as requested on, oh yeah, he sent me this on Messenger. I have difficulty creating a toolpath. So this groove here is for a tooth, for a belt. And the sides inside the tooth are a little angled. So using a 2D contour, I can't get that geometry. Using trace will remain the wall straight. Philip has a VF2 mill and a lathe. How would I machine this? All right, let's model that up quick. Open a new sketch here. Let's create a circle. See for circle, and let's go 250 millimeters. And I am just gonna go ahead here and create another circle. Sure, and let's make that 25. And let's use the vertical to make sure this one is vertical to the center point there. Let's draw a line. Oh, here's another trick for you. Did you know, if you draw a line, did you know that if you hold down the Shift command, when you place your line, that line will be tangent to the circle. See that? That's a little tangent icon. The things you learn. All right, let's do a... let's just do a mirror of, let's create a line up there, and then just do then we can put a dimension on it. That's probably what I should do. D for dimension, so it has something 20 degrees maybe. And okay, now where I'm at it, I'm gonna mirror this across this line. There is my tooth profile. Let's do a Q for press pull. And let's give this some thickness. There's our profile. How would I machine this profile using a standard mill and some cam, and still making sure that we're getting that we're doing this? I don't know what I'm trying to say here. We're getting the walls at an angle. How do we do that? So let's get it into to manufacture. And let's create a setup. And actually, since this is a round part you're trying to machine, Philip, just so you know that even though that you maybe don't have a mill turn machine, so I'm assuming you're gonna use your lathe to make the round blank, and then you're gonna bring it over to the mill. You could do a turning or mill turning setup. That will actually let you kind of having your turning tool path set up here with the Z direction for turning. And then when you get to your milling tool path, this is a pretty neat little trick here. We're gonna use if you're using a 2D contour, well, you're saying that you have a hard time selecting that contour. I'm actually gonna show you a trick for that just in a second. But you will not get the tapered walls with either in here because this is the 2D workspace. We want to go over to the 3D workspace. And anything that is steep walls, I prefer to use contour toolpath. So that's what I'm going to select, contour toolpath. And then I'm going to go over and, like I always say, I'm going to go over and select a tool. First, when we're doing a 3D toolpath, I'm going to go in here and select a metric tool. And then we're gonna select some kind of a ball end mill, and I'm just gonna select something I know will get in there, like a 6mm maybe. So we might even want to go bigger. Let's go 10mm. That's a 10mm in there. Metric and select a inches and select a metric. 10mm ball end mill. There we go. That fits a little bit better in the size. Now, when I do this, I always tell you that you should just select your tool when you do free the toolpath, and you should hit OK. Here, though, you're already noticing, Philip, that whoa, hang on a second, because you select this as a middle turn, and this is the Z direction. This is never gonna work. I want to come down the other way. In the Geometry tab, there is a Tool Orientation checkbox. If you select this one, it will actually let you get the exact same menus as you have in the setup. So this is where you can completely change things around. Now, when I do that, it will actually default to what we modeled up here. So I'm okay with that. So I'm going to hit OK. And you will now see that you get a toolpath. Now, this machine's more than you want, because it just looks at, it kind of looks from the top down and machines everything it sees from the top down. That's what that toolpath does right there. We want to narrow it into kind of like just on the teeth. This is where your problem with the 2D selection comes in. If I go in and I right click and say edit, and we go to the Geometry tab, you will see that it's doing silhouette. What is really just like taking a flashlight down on top of that part in the Z direction. If we go to say we want to do a selection, and this is where I'm going to show you something really cool. So I'm just going to slow down a little bit. If you go over here and you click, you will see that certain edges gets highlighted wherever I kind of am. And it's a little interesting here. Now, if I click on this as my selection, down in the bottom, you will see that we get like, I don't know, is that an H? A double H? I don't know what this is. Here's the cool thing. If you select this down here again, or select this down here, this little menu appears. And what you will see, it goes away, but the line that I originally selected will reappear. Now check this out. If I'm now walking around what I want, so if I select this edge, see how that turns blue? Select this edge, see how that turns blue? Select this edge. I can actually select a completely new boundary. And when it gets fully closed, like it is right now, if we hit this plus sign, see how we just created in the green a boundary that follows this outside. Okay? When I hit OK now, it will only machine within that boundary. Okay. So that went a little fast. Maybe go back and check it out again. But what you got to do that is hard about this is you got to just remember that you select one edge and then you go back again and select what it was selected, and then you can reselect. So I hope that that's a good little trick. Now, with this selected, Philip, then you will see that now we're actually getting a free access toolpath that will machine down in steps. Down, 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 down. And you will actually see we get some red arrows because at some point it's actually going to collide with the tool holder. So it gives us these warnings. Or with the shaft. Actually, it's the shaft of the tool that it gives us as warnings. But this is how you would go ahead and machine this contour here. I should also say that you can also, if you really want some flexibility, is you can actually also go into your going to your sign space, and you could open a sketch, and let's just sketch right on the plane here. You can also draw sketches. Of course, you should fully define them, but you can select those as your boundaries inside of the 3D workspace. So you saw how I before hit selection and I got this specific chain from the model. But if I exit out of that, you can actually also select the 2D sketch. And now it will use that as its boundaries. This, friends, is extremely, extremely powerful. And something that if you are fairly new to CAM, you're going to find this very useful. It's like one of those pocket tools that you really would like. If this went a little fast, go back and rewatch this section because this is extremely, extremely beautiful. All right, useful. Let's just move on here. Philip, I hope you found this useful. Thumbs up if you did. Thumbs down if you don't. Let's jump on. Next one is from Ben. Ben sent us a question last week that was about doing spokes on a wheel. So, but he sent another image today. So let me just switch my screen over. So you guys will just watch last week's. Will kind of remember the spokes on here. But this time Ben is like, all right, so I have another question. But it's fair enough. When creating a large complicated sketch, some of the lines stays blue even if I can't move them by clicking or dragging on them. I also can't add any more constraints because it tells me that the sketch would become over constrained. I'm clearly missing something about constraints somewhere. All right, so this is one that I get on a fairly regular basis, and I think it's a good question. So if we go in here, and I'm not going to make a complicated sketch, but we're going to talk a little bit about this. If I go ahead here and create a sketch on a face here, and let's do alpha line, and I just draw a line up here. Now, right now, this line is completely, I would call it live. If I go up to a vertical space here, it will actually snap in. And if you look on the horizontal line, there's an icon that gets very similar to the bottom of the horizontal vertical line. See that blue one appears? That means that if I left click right now, Fusion will associate that horizontal to this. Now if I go vertical, you will see that the sign changes to become the vertical one up here. You see that? Now there is a trick that if you hold down Control, then it will not try to snap in, what can be easy. Now if I go over here and I let it create that horizontal one, so I'm just going to left click once, you will see that that icon appears right there. So now that is horizontal. I'm just going to draw, if I move up where it becomes vertical again, you will actually see down at the bottom, it actually makes a little rectangle where those two lines intersect. That would actually make it a perpendicular relationship. But I'm just going to let it be out at an angle here. Left click once, left click again somewhere out here. Let's make another line. Now you will see that that icon on the line as I'm moving it about the middle of this line looks very much like a parallel. So right now what it's trying to do is trying to make this line parallel with this line. You will actually see the same symbol kind of appears down at the bottom line. So Fusion is doing these relationships, right? And if you're fairly familiar with this, you know that we want to try to make everything become fully defined. Now, right now, when I'm letting go of the sketch, enclosed sketch, this one is black, this one is black. That's because that they are kind of tied down, but everything else is still moving around. Whenever you have blue geometry, as to what Ben is referring to, grab a corner and start holding down your left mouse button, start dragging around. This will give you an indication as what these can do. So if we're looking at this vertical line, it's very visual that in this case, it is just going up and down. It's not moving in the X direction. It's just moving up and down. So if I placed a dimension on this, that means that now when I drag this line, it can't move up and down anymore. It's being tied in. And we're always looking to make things go black. Now, so this is a good example where, I can move certain things around and it gives me an idea about what I could do. So if I decided to do a D for dimension and hit these two lines and give this an angle, that means when I drag this, you know, that is going to be tied down. If I hit a D for dimension and place a dimension there, now this whole thing is black, and now I'm only left with one movement here, and I'm only left with one movement here. So if I do a dimension on this, the last movement is really just this angle, right? So that is what we're trying to do to get things, you know, locked down. If you are in the situation that Ben is in, where he's like, well, I got all these, this is a fairly complex sketch, and there's things in here I can't get it to lock. No matter where I drag it, it will not move. And what happens is, when he's saying about overdefined, is that if I place a dimension here, so this line has a length, this line has a length. If I tried to go, actually a better one is to do this. If I decided that I want to say that these two lines should be equal, that means that now these two lines will always be the same length, because I applied that equal relationship, meaning this one is controlling that. If I'm trying to place a dimension, you get this warning. Now, this is not an error message. It's just a warning that if I'm adding this dimension, it will be in brackets, what means that it's not doing anything other than just letting me know what the length is. What in this case, it's the same as this. What I do, Ben, when I have something like this, is you kind of make, you can make two decisions. You can either say, I am just going to leave it. I have dragged every corner. Apparently there's something that I'm missing in here. Something else is moving, and I don't know what it is. And I'm okay with this because it's just, I can't find that issue. The other thing you can do if you have a blue segment is you can right click on it and you can say fix it. And then it's actually going to turn green. What just means that now it's locked and this is not going to move. It's glued to the background. That is probably the most secure thing. The only problem that can become with that is that whenever you're trying, at some point, if I go in here and I delete, if I go in and delete some of these relationships, is that this line can't move now because it's attached to this one that is glued to it. But of course, you can always right click and say unfix, and then you're kind of back in that same area there. So, Ben, I hope that answers your question. I right clicking and fixing it is actually probably the proper way to do that. Hope that was useful. This is just me trying to get through some of my emails. I'm not spending a lot of time on preparing or sorting. I'm just kind of going through it. Next one is from Kevin from Bombay. Hey, Kevin. Just now, okay, so watching some Camp Basics videos, and they were good. Really appreciate you like them. I am building my own 5-axis micro machining system, so I need to generate G-code for that. So can you suggest me some good sources by which I can learn multi-axis cam within Fusion? I really can't. Sorry. So inside of Fusion, there is, if we open, let's finish the sketch. If we go and open a new document and we go into manufacture, there is in here multi-axis. So there's some swerve cutting, there's multi-axis contour, there's a flow toolpath, and actually also, if you didn't know, in a 3-axis, like a contour toolpath, there is actually also multi-axis tilting that you can turn on in here. It has been on my agenda for a long time to create a video on multi-axis or 5-axis machining, but I haven't gotten to it. And I honestly looked in, And there might, if there is some, and if somebody out there is watching this, you're familiar with it, do me a favor, throw them down in the comment area, because I'm actually not familiar with it. It's on my agenda. I just haven't had the time to really dig in there, and because if I gotta create one, I want to try to make it a good one, and this format is not really good at that. So sorry, Kevin. Somebody leave down in the comments area if you have a good answer to Kevin. All right, next one is from Dean. Hey, Dean. Having a challenge getting a functionality quest in Autodesk. So they are currently using MasterCAD Timber File in CAD work. I'm not familiar with that program, but it's for building. So Dean sent a image. What he's trying to do, whoops, I just closed the folder down, is this cross section for a building, what is kind of cool. Now, Dean, I should say, I want to say up front, it's important to know, and I've said this in other of these videos, that Fusion is based on mechanical CAD, not per se building things. That means you can't do it, but there's other programs that might be better. Like something that comes to mind for me is like Autodesk Revit, for example. That is probably more for this, but what you're trying to do inside of Fusion, I don't think is completely impossible. There's a couple of different ways we can work with this. So let's take a look at this. So I'm going to try to just model something up quick here. Let's do something, and I'm not going to fully define this. I am going to build a building. So let's do something like find the midpoint of this, maybe draw a line up to there. Okay, and I'm gonna draw this. This is not gonna get pretty, but that's okay. Let's make these two lines equal. Actually, let's make them also not equal. Let's make them parallel. They're not going to be equal because of the way I designed them. And let's then use that construction line to mirror this over there. Okay, let's hit Q and hit press pull. What do you think of my house? No comments? All right, so you got a couple of different options, Dean. So what I'm assuming that you're trying to do within Fusion is to 3D model up your buildings. So you have all kinds of really cool details in there. Looks like there's some shingles on the roof and all these different things. Then trying to do a cross section. Now you have a couple of different options in here. Now, first of all, I want to show you that you can, of course, if you right click on one of the bodies, you can actually apply colors to it. So we go in here, maybe do a glossy paint, and do something like we could make the roof green, like that. You can also select faces. So we could actually go in here and say that we want this face to be blue and this face to be blue. So you could break it down into different colors, whatever you kind of want. Now you could choose to say, I want to do my section inside of the 3D modeling environment if you wanted to show that in here. And you could do that. We almost did that already early in the video with a piping scheme, but I mean, we could go in here and create an offset plane, cut that through there, and then we could do like, split body, and we could split the bodies with that plane, and then delete the bodies that we don't want to keep out of here, and make kind of like a section like that. But when I'm looking at your drawing, we are looking at getting some notation in there, and that is probably where the 2D drawing environment starts becoming useful. So let's just save this one. So you're gonna have to save it. So I'm gonna hit save, and let's save it as Dean outside wall. That's We gotta save it first. And let's go into the 2D drawing environment and say from design. And we're just gonna select everything, hit OK. And now it's gonna open up in a 2D drawing format, right? It's just gonna take a second here. I'll get a sip of my coffee. Happy Father's Day to everybody who's watching this on a Sunday. And of course, you gotta set your drawing templates and all. There's videos on that. But you will see here that one way to do this is just to go in and if I just place this view like this, you might say that that is exactly what you want. Now, if I just hit OK, it would actually turn just white and black because 2D drawings primarily looks like that. But if I double click on the view again, the menu comes up. You can actually just turn the shading on right here, and it will bring in the shading from Fusion. Now, this, though, is not really what you want because you want a section view. Very clearly, this is an outwall cross-section view. That's what this says. So instead, I'm going to go in and do a projected view from this. And when I do that projected view, so that's kind of the side view. See, there's the 3D view. The side view here, so now we're looking at the side, you can use this as your tool. So there's a section view here. I click on that. You select where you want a section. So I'm just going to select somewhere on your wall here. Hit enter. And now I get that as the section. So this is actually looking through as if you were standing at the end and you cut right through here and you looked at this. So this is actually what the section looks like. And when I hit OK, you will see that we get what we call hatching in here. And this is very common to CAD drawings, that there's hatching in there. I don't know if you had hatching. You didn't have any hatching on yours in here. What you can actually do inside of Fusion, and this is probably another trick, if you go and you select the hatch, double click on the hatch, on there you actually get a menu where you can select a different ANSI standard for that hatching. But it's pretty cool, and you can scale it up if you want to. You can do different angles and things like that. So know that when you do this, you can get the hatching in there and you can control that. Same for the other, but if I double click on this, we get the other hatching in there and we can get the different hatches and control those. Now, so this is probably what you're looking for in here. What you can do is, and you can do the hatching. I literally did a section straight through here. If we just delete that, you can actually also select this view. We could have drawn down and come over and down like this and hit enter. And now the section view you see is actually cut as you're looking down that section. So this can be pretty crazy. But the reason you want to do this in this view, Dean, is that you, of course, in here have the option to set leaders. So now you can go ahead here and you can place a leader and you can call this outside wall, and you now have this section view. All right. So I have done, if you search, so if we go to YouTube, search YouTube, Fusion 360, and maybe live stream. See what we get. If we do that, we actually are getting some of. Look at all these different live streams by the Fusion team. This is awesome. Those guys are awesome. Let's just go into Fusion instead, or into YouTube instead. There is Brad doing his. If we go up here and we search let's search LarsLive instead. Lars, whatever. There's another LarsLive. LarsLive Fusion. There's got to be some way to find my. Alright, we go to my YouTube channel. You hopefully have another way to find it. Did you see my new banner I made? If you go in here and you go to playlist and you go to the 198 live streams I did, click on this one a little up here, and you will get the entire list in here. If you scroll, make sure that all of them get loaded. So just scroll all the way down till you see 198. Now, if you do a control F, then you get the find section right here. And if you type in drawing, if you can spell drawing, you will now see that there is 3 different 2D drawing environments in here. So you can go and look at those if you want to get more into to the depth of how to do this. I hope this was useful, Dean. Fun little example. All right. Next one is from Gianni. Hey, Gianni. Hope you're doing well. Gianni has a question in regards to Cam, and also sent an image. That's always wonderful when we get those. He sent this image and said, "Can you help me? So I'm using a 5mm flat end mill, and I don't get any rounding of fillets in the small holes. The holes become too small, and I'm imagining what you're probably doing is a little bit the same as what happened earlier with the tool belt. So in the tool belt example, what was that? I have a lot of ones. This one, it looks to me like that you are selecting a flat end mill and a flat 2D, and you need to get a 3D toolpath. Let's take a quick look. So let's try this. If we go in here, and it looks to me, when I'm looking at your image, I'm wondering if you're trying to do like a counterbore maybe? I don't know. It looks like that. Maybe it's offset down. So, quick look at this. Let's open up a S and do a rectangle like this. Let's extrude that up. Let's put a hole in it. So let's go hole. Select the hole right there. Let's select this to a counterbore. Let's do it a 15mm diameter, something like this. So it has a taper on it. Now you actually said that there's no fillet. So I'm wondering if you maybe have a couple of fillets. Maybe you have a fillet here and you have a fillet here. So let's put like a 5mm fillet on the hole, something like this. So when you're machining this, when you're going into your manufacture, if you select something, you might even select a adaptive clearing in here to do this. So let's do that. Select the 3D adaptive clearing, and let's select a tool, metric tool, and let's select a 10mm flat end mill. Hit OK. And always when we're selecting 3D, we can hit OK and see what we get. And we get something inside of the hull, but it's also machining the outside, right? So let's go back in and edit that. And let's go to the machining boundary, and maybe we select selection, and we select this outside edge here instead. Hit OK. So now it will contain within that. Now if we go and simulate this, so let's turn stock on, we get something that I think looks very similar to what you have on your image, right? We kind of have these step downs, but what we are looking for is actually a smooth surface and the fillets. And that is because the adaptive toolpath using a flat end mill will literally just do each step down. If you are looking to, if you still want to use, you probably want to use a ball end mill to do this, to be honest. But if you still want to use a flat end mill, you can. You probably want to do the same toolpath we used earlier. What is the contour toolpath? Select that. And let's just select that same selection there. Hit OK. Now the contour toolpath will give you the radiuses, but you're gonna have to make the step over extremely small. So right now it has a maximum step over of 1. So now you maybe have to change it down to, now it comes down to how much time you have in your life, how long it's gonna take. The finer you will get in this, the more the more accurate it's gonna get with this flat end mill. You can see that it turns completely blue, and it took a lot longer to calculate, but in the end you will end up with something that will resemble, I have a little bit of extra stock on top, that's why you're going to see a little bit of step here, but you will end up with something that resembles the radiuses on it. If you're using a ball end mill, then you will actually end up with something that looks a little bit more right. Let's see here. All right. Okay. So that is that. Hope that's helpful. Moving on. Next thing. Next email. I hope this is useful. We're almost on an hour. But hopefully it's useful. All right, the next one is we have some 3D printing coming for anybody who's losing their patience. Another one. I'm trying to understand, Cam, what does the colors mean for each cut? I'm expecting to cut till there's no more colors. Why is it that when I use a ball tool and use another tool to smooth it out and rest machining? All right, so this kind of like relates to the other one. Let's just do that one quick. So first of all, you can get different colors in here when you are simulating. And I can't for the. If we go in here and we do tool, we have 2 different tools. I think maybe it gives us. I can't remember how to set the. I think I've changed mine. So this here, and then when it gets to the next, it's not doing. Which one is that? Somebody's yelling at me right now. There's one of these that will give you different colors. Oh, well, that was kind of what I was looking for, but not. All right, somebody's yelling at me. It's got to be one of these. Operation, is that giving you different colors? Is that it? No. I can't remember how to turn that on. When you're simulating in here, sometimes it will give you different colors. So to answer that question, no. Maybe I shouldn't have attacked this one. No, the colors just tells you different operations. So like the face mill will get one color, the next tool will get the other color. You're not looking to remove the color. That is not really part of the simulation inside of Fusion 360. It doesn't give you the option. So we'll display the different colors to show you this different tool path. So one is a facing, one is the other one is a 3D surfacing tool path, but you're not looking to remove the colors. That is all done in your model. So you make your model to nominal, and then in CAM, you will just machine to those models. The other one is about rest machining. Why is it that when I use a ball tool and then use another tool to smooth it over more and select rest machining from the previous operation, it does nothing? That is because rest machining will only machine where the previous tool couldn't go. Meaning that if we're looking at our current example here, and we're selecting that 2D operation, if I go back and I change the step over to 1 millimeter, like this, and let's go in and actually change the tool diameter. So let's go in and change it to a 16 millimeter flat end mill. Okay, now you will see that the machines Actually, hang on. Let me go back. 10 millimeter tool. Okay. Forget about the additive. Now you will see that it machines the whole thing all through the hole. It's doing this. That is your first example. So now we have a roughing toolpath. I right click on it. I'm going to duplicate it. So I'm going to make a copy of the same tool here. I'm going to make that a smaller step over. So it kind of like a finishing toolpath. So let's just make it half the size, 0.5. So it doesn't take so long to calculate. So this is a finer step over. And you'll see it does this. Now, if you go ahead here and you right click and you turn on the rest machining from previous toolpath and you hit OK, it's not going to give us anything because it is looking at the previous tool and says, well, the previous tool got everything. The previous tool got everything, so turning rest machining on, there's no reason for that. So what you want to do is you don't want to turn rest machining on for this. You just want to leave your new step over a little bit finer so you are smoothing it over. Now, if I go back and changes that tool on the first operation to 16, now you'll see the first tool cannot get down in the bottom of the hole, right? Now, if I go into the second operation and I turn on rest machining, this will now say, okay, now this operation is looking at where the previous tool couldn't go. What, in this sense, is the bottom of the hole because the first one couldn't go down there. So I hope that was useful. A little cam into another one from Aiden. Thank you so much. Appreciate that. Next one is from Karupik. No, from Gamse from Karupik University. Hey Lars, I'm studying at Karupik University in industrial design engineering. Good for you, man. I was asked to design a brake pedal using Fusion 360 General Design. All right. For my undergrad. That's awesome. I did a few design solutions about it, but some things went wrong, and I'm trying to figure it out. Could you help me? Sorry, dude. I just don't have the time to dig in and help individuals with their projects. I'm sorry. The best thing to do is actually to utilize the forum for that. So don't forget that at any time you can go out to the Google, and if you type in Fusion 360 forum, do that and post into the forum here for some help. And there's people out here, and there's other people, many of them probably watching this video. Truly appreciate all your work. Go there, Gamsave, to get it. I just don't have the time. I'm sorry, man. I would love to help you. I don't have the time. Next one is from Bernie. Hey, Bernie, I am making a number of assemblies for 3D printing. I told you there was going to be a 3D printing in here. I'm just asking questions. So if all of them are cam, then they're all going to be cam. I don't know what else to tell you guys. So I would like to know, is it better to add tolerances for the 3D part in the sketch before you make the body, or after by projecting the body and adding the tolerances there? So I love this. This is a good topic. If you go back into the live streams, you'll find out I talked about this before. I get myself in trouble. Tolerances for 3D printers. You got the Ultimaker right over there. So how do I recommend doing that? Actually, I did a video. If you go back out to Fusion, if you do, I think it's called My Mistake 3D Printing. That's what I called it. Right here. My first 3D printer mistake using Fusion 360. In that video, I talked about some of my learnings with using this awesome Ultimaker, and I brought up that I made some gauges, because when it comes to figuring out tolerances on your 3D printers, it is a little bit of a nightmare to try to figure out. What I did was, if we go over here, and why? Oh, did you know that you can sort this all here into, I always like last updated. Click on that little gear icon. So what I did was I created these gauges. And I will tell you that if you are, remind me in the comments, and I put a link to this file. But if in this, you will actually see in this video, it is right there. You can download these files here for free. Just go and download these when I model these up, because every 3D printer is different, and it's hard to find out what kind of tolerances should you have when parts needs to fit together. And you have two different options inside of Fusion. Two, maybe more. You have a couple of different options inside of Fusion 360. I would personally drive it by the dimensions in the model. So when you're sketching things up, so if we go using this gauge, for example, we go and edit this sketch, you will see that you can adjust it. So what I would do, what I did was I made this little gauge here. I printed this out, these two out, and then by taking one and to put it over to the other, you can kind of see how they fit and figuring out kind of what the tolerances are on your specific 3D printer, because there is no rules. Now, if you find out that, for example, the one here that is 2 inches by 2,000 fits very well with this one, then you know that when you're trying to fit two things together, that in this case 4,000 might be a good tolerance. Then when you are printing or modeling things up that gotta fit together, then you apply that tolerance to your sketch. So you would actually go into your dimension and adjust it in here. That's what I would do. You could even be fancy and go in and, if you wanted to, and create one of those parameters. And in those parameters, you could create a parameter that you call your 3D print clearance, and put that, whatever that value is that you decide it is. Now remember that clearances changes depending on sizes. So the more surface area, normally you need a bigger clearance area. But you could apply this one in here, and now from now on, whenever you are doing something in here, you could just add that to whatever you wanted. So if I went in here, if I had to make an adjustment, two things had to fit, now I could just say plus, and I could add that clearance in there, whatever. Maybe I'm going a little bit sidetracked. So this is one way. That is absolutely what I would do. Hands down, I would primarily do that. But know that you do have the option to offset a face. If we hit a Q for press pull and we select the face, we can actually add in here. So I can go minus that whatever it is I want, and this is now going to get a little bit smaller. So no, or if I go the other direction, if I make it, bigger, I can actually offset this face and make it a lot bigger. So be aware of that you have different options. I would absolutely say, for me, for what I'm doing, I am always doing it in the sketches. It can be a little bit of a pain in the neck, but that's what I would do. The other thing, and I hope this is useful. So again, that file, download it. The other thing, Bernie, you're talking about is that if you are using the whole thread tool inside of Fusion, just like we did the counterboard a little bit earlier in a video, if you're using the fret tool, that it actually makes the hole smaller or changes the size when you apply a thread. Yes, and that is because Fusion, being a mechanical CAD tool, is using the Machinery's Handbook to do the threads, and I have made a video about that. So it actually adjusts the thread to be right for the Machinery's Handbook. What it means if you were drilling and tapping and machining, you would do that. So you're going to have to adjust for that. Now, of course, don't forget that you also in here have the scaling tool as one of your magic ninja tools in here. So if you're doing a thread and you find that it's tight, you might just be able to scale things up playing around with it. But this is one of the things when you have a mechanical CAD tool that you're going to have to do that work with your 3D printer. Bernie, I hope that was useful. Go and check out that video. Download that Gates 3D print it out. Again, if I'll leave a comment if I don't remember, and I'll test that file, and you can download it that way. Next one is from Robert. Hey, Robert. Robert is from Sweden. Hey, just want to tell you how much I appreciate your Fusion 360 videos. Hey, Robert, I really appreciate you taking the time to sit down and write me an email about that, man. I appreciate you watching. Okay, we are about an hour and 10 minutes in, so let's see if we can't wrap this up so you can get on with your life. Next one is from Rusty. Rusty is from Canada. Love Canada, right? Like an hour away from, 45 minutes away from Canada. Love Canada, sitting out here outside Buffalo, New York. And I wanted to do, normally I don't like to download people's files because it's just extra steps. But Rusty, being from Canada, bought an OBA file that he has some troubles bringing into Fusion and get to work on his 3D printer. I thought that I would make an exception for Rusty. So I did bring in his file. So let's open that up. So Rusty went out and bought an OBJ file. So you can go out and Google and you can search things out and look at it. And this is a pretty dang cool file, Rusty. Now the problem Rusty has, I think, if I understand correctly, is that when he brings it into his 3D printer, everything looks fine, but when he's trying to print it, it doesn't work. And it looks like it's all just like shells. So what I did, I brought this in. It's an OBJ file. Rusty bought this. It's really beautiful. Look at this thing. But when I click on the bodies folder, Rusty, I get this. It all looks like mesh. And then you guys who have been around for a while says, well, that's cool. We can work with mesh files inside of Fusion. So what I'm going to do is I'm going to select this second one. I'm going to go down to, hold down my shift key, go to the last mesh file, and just hit V. That's going to turn all those off. So I'm just going to narrow it down to only having one mesh file so we can look at it a little bit closer. Rusty, when I look at this, I notice that it doesn't look like there's any thickness to it. You see that? It just looks like it's paper thin. And actually, if I do right click on this and say mesh to be wrap, what is our trick here? Hit OK to that. When I scroll down to the bottom, I actually see that this is a surface body, not a solid body. And that tells me that this here is a shell. There's no thickness, what means that, of course, on your 3D printer, when you go to print this, you are going to be in trouble because it doesn't have any thickness to it. Now, you could try to thicken this, but I think you're going to have some trouble with it. Let's go into the surface toolpath. Let's select all this and look at this. Just in this little piece, 6,882 surfaces. I didn't try this before this, but I think you're going to have a trouble. You can go in here and we could look for, if we're going to create, we could go in here and where is it? The thicken. There should be a thicken in here, isn't there? That is not a thicken. Why is it not a thicken? Am I missing it? Somebody's yelling at me right now. Trim, trim, trim. I thought that would be a thicken inside of... Oh, right there. Jeez. You could try and go in here and thicken this. but I don't know if Fusion's going to be able to handle it. I mean, 6,882 faces, and try to turn this into a solid might just bring Fusion to its knees. I should probably have tried this before I started recording this. Honestly, Rusty, I think you're a little bit out of luck. I think that you have selected a file type that doesn't really fit for a mechanical CAD tool. This is probably, there might be other software out there that would help you better at thickening things. But let's just try to thicken this 5 millimeters maybe. And it says me down here, the operation could not be created valid result. It's probably just because all these surfaces are overlapping, you know, like one of these garbage in, garbage out kind of deals. If there is a solution to this, I honestly think that it might just be something else. Maybe somebody has another solution for this, Rusty, but I wanted to bring you in and at least give you the explanation why you're having issues. If there's somebody out there who does 3D printing, who's a lot better at 3D printing than me, please, in the comment area, help Rusty out. He's paid money for this file. Next one here is from Tyson. Hey, Tyson. Thank you so much for your help with Fusion. You're so welcome. I was thinking if I could buy any of those shirts you have been getting from trade shows, or you could guide me to where you get them from. So most of the shirts that you've seen me wear, except this one, because this is an Autodesk shirt, but the latest shirts that you've seen me wear for the last year or so, I all bought them on Amazon. So all my cam shirts that says funny things on, just search, CNC programming t-shirts on Amazon, you get those. This one here, this is actually an Autodesk shirt. So Autodesk actually have this shirt I actually got from one of you guys. There was a user who sent me a t-shirt because he knows I like to play the guitar. What is awesome. But if you go here to Autodesk merchandise, you can actually go and you will find that there is clothing in here. You can buy all kinds of cool stuff, and there is the t-shirt that I bought. Yeah, so you can go and check that out. All right, let's see if we can wrap this up. Next one is from James Carter. James is asking about a bond. I don't know if I can say this. Abandoned. I can't say this in English. Bottom up completely. File structure. Part file structure advice. This is a pretty long email, but from James, first, many thanks for your YouTube videos. Hey, you're so welcome. Having used Inventor previously, these have been invaluable in getting up to speed with Fusion. Glad. One part that still confuses me is about part file structure. And it's about doing the bottom-up approach or what is called top-down assembly. So there's a different questions in here, but one of them is, I feel like abandoning is what I'm trying to say. Abandoning bottom-up is only way to model in Fusion. Do you also feel like that? So, first of all, there's some people out there saying, abandon. Too stupid say that. I'm sorry. You like these videos? Thumbs up. If you don't, thumbs down. That's okay. Comments. The guy can't speak. It's horrible. Some people are saying, what the heck do you mean about bottom up versus top down? So let's just talk about that for a second. Get into Fusion. Let's open up another file. So what we call bottom up is what I would say normally is how most people learn how to use Fusion. And I still use this technique. So what it means is you start a sketch on a plane, you draw something, a sketch, like this here, and then you maybe extrude that up, like this. Then you create another sketch, maybe on that top face. You do C for circle, not even hit the center, doesn't matter. You fully define that. You do another extrusion, right? You're getting the picture here we're building on. Then maybe we say, all right, now we want to we want to draw another sketch, and I might even select this face here, but I draw a circle up here and I cut through here. This is what we call bottom up. And the reason that it's bottom up is that it kind of starts from the bottom, and each of these are building upon one another. It's cool. The other approach, let me open another file, is top down. And what top down normally means is normally used if you have multiple parts. So you're trying to create multiple components that fits together, for example. In that sense, what you could do was you could start another sketch at the top and start that sketch, and then you maybe draw the same thing we did before. You maybe draw a rectangle, but maybe instead of extruding that one out, you could be fancy and continue to draw things in the sketch. So now we have two things in here. Now I might even start another sketch on this face here and maybe draw a circle up here. Now what the top down means is that when we have drawn some of these helping sketches, maybe now we start creating extrusions from these. So I go in and maybe you even start new components. So there's going to be one component, right click that, and that component is now going to be extruded from that sketch I originally created. So that's one component driving from that original sketch. I might say I'm going to draw another component, and that component is also driven from that original sketch. So I select that and I draw that up. And then there might even be another component or another feature that is driven from that original sketch created in the beginning. So if I hit Q, and now I might select that inside profile and using that to cut with. So you see how it's kind of two different ways to do things in here and working in the two. So to go back to the original question from James is, do I abandon one to go for the other? And my question is, personally, I'll say I'll do either. But many times it's because I like to, as much, and I know that this is going to frustrate somebody, so I apologize. But as much as when we are working with CAD, we're kind of looking for like that golden ticket, that one, do this, and then you're all good. And don't ever worry about this other thing. But if you're doing this thing, then you're all good. The truth is that that is not how the world works. Most people, we already know this in other portions of our lives. As much as I like to grill my steak 3 minutes per side while I'm enjoying a cold beer, it can't be done on the stovetop, right? And some guy will even say that it's better to do it in there and throw it in the oven, whatever. So what my rule is, should watch out with rules, shouldn't I, James? My rule is that if you're modeling things up that's going to have multiple components in it, then doing the top down is probably the easiest. I talked about in a previous video, I think maybe actually last week, we were talking about Rob Lockwood, my good friend Rob, talking about using master modeling as a principle. And so maybe go back and check that video the week or the Sunday before that. Master modeling is kind of like the top-down approach. And if you're getting into more complicated things, bigger parts, then master modeling or top-down is probably the most flexible. But if you are fairly new and you're trying to get things going, bottom-up is still the best one. And you will have seen, if you're looking at all the different topics that has been covered today, these ones here was modeled bottom up, and I didn't do these in a tutorial. This was actually just me modeling things up. This was modeled kind of like bottom up. Most of the stuff that I'm doing is bottom up, unless I'm getting into something that is more complex. You're trying to add things together. Top down. All right, last one, and then we're gonna wrap this up. We're about an hour and a half. That's I'm getting too wrapped up in this. Just me trying to clean up some of my emails. Hope this is useful. If you like it, thumbs up. If you don't worry about it. Last one here is from Gaetan. I think that's how you pronounce your name. I'm not quite sure. I was wondering if I may ask for help. And we're going to end this one on cam. In the cam simulation, there's an option to save stock. Generate stock from a machined model. And I watched one of your previous videos where you did not mention this. Can you explain that? Yes, I can. That's what we're going to end with. So, I'm going to do this quick. Let's go back to this one here. So, we have machined a couple of different holes here, right? So, if I go in here and I say simulate, and we kind of play through this, we kind of rough things out. Not great, but we're roughing these holes out. What means that if I turn the stock on, in the end, we will actually have that, right? Now, if we wanted to use this plate for another operation, and we wanted this hole to already be in it in another setup, yes, you can actually save this out of stock. I know that the cam team would probably love to do this in a little different way, and they're probably working on something that I'm not aware of. But there is a way to do this, but I don't think it's it's probably there's a better, the developers of Fusion are extremely smart. So hopefully someday they get to this. But what you can do, you gotta simulate through, make sure you're in the simulation space, play all the way through to the end. Then what you can do is you can right click, and when you do that, you get this save stock. And then you can say save stock. And you can click save stock, and it will actually let you save the stock out as an STL. That actually means you can 3D print it. That's kind of cool. You can save that out, okay? And now in a completely different CAD file, you can go in here, you can go into manufacture, right? And you can actually, if you apply a toolpath to this, it's like the 2D adapter doesn't really matter. It's like some kind of a tool. And then when you're in that, well, actually the way I should show it is, now I'm winging it. So now you want to machine the other side, but you want that as stock. Yeah, that's how I should show it. So we saved out the files. So still do the same thing. You go into simulation, you play through the whole simulation, you right click, say save as stock. Then when we now want to machine the other side, so I'm going to create a new setup. This is going to be the other side I'm going to machine. So I'm going to go in here. So this face, hit OK. Now I'm just going to do a facing operation. Facing operation of this part. Right? When I simulate this, if I just go and say simulate right now, we don't see the hole. But what you can do now is you can right click, go in here and say load stock. And now you can select that stock model, and then it will come in as that is already finished. That's how you do that. You could bring it into another file, like I was just doing over here, but then it will actually, proportion will go away. This was a better way to show it. So you will see that when we're going to simulate this, when we go in here now, it doesn't show anything. But if you right click and say load, and that stock that we had here, then it will open up and it will bring it in. So now you can see it. Hope that was useful. That's it, folks. Whew. I feel like we're a little bit over the place, but we covered a lot. We covered some modeling things, best practicing, CAM, 3D printing, mesh, STL file, or not STL files, but mesh files. So that's it. An hour and a half we're coming up on that. If you're watching this on Sunday, then I want to tell you tomorrow, then I will tell you happy Father's Day. You deserve it. Have a cold one. If you like these videos, thumbs up. If you don't, it's okay. Thumbs down. Can handle it. And I love your comments. And it's just me trying to add a little bit more value to your day. These emails was all sent to lars.christensen@autodesk.com. This is my weekend project, just trying to help out and provide some content. So, that's it. Until the next time, I hope you have an awesome, awesome day. Take care, folks.